This is Computer Science 2124, video 11. And let's get in the terminal here. And I'm going to do an example of what a run of Program 6 might look like. It's got to have the Program 6 driver program and also your slist.cpp class. And you'll remember the slist.h is pulled in using the include, a preprocessor directive. So don't need that on the command line. /a.out will run it since I didn't send it to any particular output file. And here's all the things I can do. Notice it's saying that it's using list 0. There are 3 lists possible in the driver. 0, 1, and 2 is just an array of linked list objects to make sure that all these list things only affect the list they're supposed to. And all these operations, I can insert, I can remove. I'm going to try the ones that are not going to be successful initially. Just to make sure, that's testing the boundary conditions. Look at this. I tried to remove. No item removed from list 0. There wasn't anything there, so it returned failure. And then it shows using the print debug, which I gave you, or perhaps you wrote your own. It shows what the current contents of the list, and it also shows what get receives. So it's automatically going to print out the entire contents of the list, and it's also automatically going to show what get will return. Let me do a move operation. The menu's down here at the bottom of the screen, as you can see. And when I did a move, failure. It didn't move to the next list and like next item in list 0 because there was no next item in list 0. What else? Can't remove. Can't move. Can I move to the last? It did move to the last, and notice it's not returning success or failure. We can always move to the last node because in this case the last node is the empty head node. Same thing, moving to the front, move to the first list, and there we go. And 10, I'm just going to go ahead and change to a different list. Tired of list 0 already. I'm going to use list number 1. So this should only affect list number 1. I'm going to put something in there, finally, with an insert operation. I'm going to put Buddha in there. There goes Buddha. Now let's stop and see where we are. I moved to list 1. I did an insert operation, inserted Buddha into list 1. And current contents of list 1, it shows me the entire contents, and it also shows me what get would retrieve. Get retrieves Buddha because the cursor, if your constructor is working correctly, the constructor positions the cursor to point at that empty head node, and empty head node arrow next will be Buddha. Let me insert it. You know what? I'm going to turn around, test the boundary condition already, and remove the only node that's there. See what happens. And there, success, removed, item removed from list 1. List 1 is empty again. Get retrieves nothing, and the list is empty. Now I'm gonna put some stuff in there. Quit messing around. Let's see. No item removed. 1. I need to do a 1. That's what I need. String Michael. And another 1. Solomon. I'm gonna put several in there and then stand back and look and see what I got. 1 again. Leo. 1 again, Trout. There he is. 1 again, Darby. Move, Trout. Move. Don't. Okay, now, well, they went in backwards. Well, if you think about it, every time I do an insert, it's going to insert a new node that will become cursor arrow next node. And the cursor hasn't moved since the constructor. So the cursor, since there was no compelling reason to move it, we leave it alone. It's still pointing at the empty head node. So every time, you might have noticed here, every time I inserted a new node, it became the new first node in the list. That's because cursor never moved. Now, I'm going to do nothing but move and see what happens. First of all, here's the list. Darby, Trout, Leo, Solomon, Michael. And get retrieves Darby, which indirectly tells me that the cursor is pointing at the empty head node. So let me move. 3. Move to the next item in the list. The list stayed exactly the same. All that happened was the cursor moved. So now the cursor is pointing at node Darby. And since Darby points at Trout, when I call the get operation, Trout is what it gets. I'll move again. Now it's pointing at Leo. Now let's think about this for a second. Trout, Darby, Trout, Leo. So get retrieves Leo. That's at the cursor arrow next position. Solomon and then Michael. So can you predict before I have time to type it what's going to happen if I do a remove right this minute? Who's going to go? Goodbye, Leo. Look what happened there. The get operation retrieved Leo, which meant the cursor was pointing at Trout, and Leo was what get retrieved. So if I turn right around and call remove, then it got rid of Leo, the middle of the list. Now, a couple of people, and I suppose everybody eventually gets a little, not stressed out, that's too strong a word, gets a little perhaps confused. If we do this, let's move to the last item on the list, 4. Last item of the list, look, get retrieves nothing. That's because the cursor is pointing at Michael if it's implemented correctly, and this one is implemented correctly. So the cursor is now pointing at Michael. The get operation retrieves nothing because there's nothing after Michael. Same thing for a remove. If I try to do a remove right now, it says failure, no item removed from list 1. That's because the cursor is pointing at Michael. So I'm going to move it back to the front. Now I can't do a move. I could try to do a move. Move to the next node on the list is 3, and that one did not move. Why? Because it's already pointed at the last node in the list. So I can what? I can make it point at the first node on the list, 5. Now it's pointing at the empty head node. The empty head node is pointing at Darby. So if I were to do a remove right this minute, remember that L shape, that magic L shape. If I do a remove right now, operation number 2, poof, there went Darby. Darby went away. And Trout is the new first one in the list. The cursor is still pointing at the empty head node, so the get retrieves Trout. Now, why are there 3 lists here? You only implement 1, but remember you're implementing everything there is to know about this one object, this linked list object. The main program has an array of 3 separate ones just to make sure that you've kept all those independent. Let's see here. For example, if I were moved to a different list, I haven't used list number 2. No, list number 2 yet. So now I am. List number 2, using list 2. So if I were to put some stuff in there now, let me put an insert. That should not affect the Trout, Solomon, Michael list at all because that was list 1 and now I've left that behind. Let's go with Scout. Look at this. Trout, Solomon, and Michael are still undisturbed in list 1, but Scout showed up in list 2. And if I were to insert Paprika, Paprika went to the front. What if I want to put a note at the end? Well, that's easy to do, or so I'll claim. 5, move to the, no, that's move to the first. 4, move to the last item of the list. Since the cursor is pointed at the last node of the list, there's nothing to get. But if I turn around and do an insert operation now, still in list 2, with the cursor at the end of the list, let me see, who am I up to? Bella. Look where Bella went. I had moved the cursor to the last node, which was Scout. So when I do an insert, it inserts Bella, and now there's also something there to get. If I want to put another last node in the list, then I got to move to the last again, or in this case, I can just do a move. I'll do it the alternative way and just move to the next item. And since it moved from Scout to Bella, it's now pointing at Bella, and there's nothing to get. And if I do an insert, number 1, Clay, then Clay goes after Bella. So I've got Paprika, Scout, Bella, and Clay. And list Trout, Solomon, Michael is still exactly the way it was when I last left it. Which of these has not been demonstrated? We've done an insert, we've done a remove. Let me, let's see. The get retrieves Clay. Now in this case, this would delete the last node of the list. Let me go ahead and delete that. Remove 2. There went Clay. But the get retrieves nothing because I just now got rid of the last node of the list. The tail should be pointing at Bella at this point, and so is the cursor. Since the cursor is pointing at Bella, then there's nothing to get after the Bella node. If I want to get rid of any other nodes, notice that remove is going to return failure at this point. Failure, no item removed from list 2 because the cursor is pointing at Bella. If I want to get rid of everything, kind of do the destructor's job for it, then I can move to the first item in the list, which is 5. And then just do remove over and over. Remove will get rid of Paprika. Bye, Paprika. Remove gets rid of Scout. Remove gets rid of Bella. And remove fails. No item removed from list 2. Now then, that was insert, remove. We've done move to next. We've done the last. We've done the first. We've done the change the list. Just to show that I can change back and forth, I'll go back to list 1. And let's see. List 1, we're currently pointing at Trout. If I want to get rid of Solomon, I will have to do a move operation, not move the last, but do a move operation to the next. Now it's pointing at Solomon, and whatever is gotten by the get operation is the same thing that should be removed when I do a remove operation. So there went Solomon. And I think that's everything. If there are other special requests for what does this program need to be able to do, you have to bring it up during office hours or class session or send me an email. There's all kinds of ways to communicate with me now. Until then, I'll just do 0 and quit and stop the video. See you online.